start with it. Okay. Now, it's an example of, let's see here, share the screen. It is an example of a percent change problem, and I thought we might use it as a little warm-up today. So I want you guys to take a stab at that. There it says example 10, Bill's new car loan. Said that he would pay $48.66.25 in interest. This is a simple interest kind of problem, and we want to know how much did he borrow. So this is the unknown here is going to be different than the example we looked at yesterday. And again, as a reminder, just in your notes, if you needed to reference back, this was the formula that we talked about right here. I equals PRT. I equals PRT. That's the formula you're going to be using for this problem. Yes, sir. I can zoom in a little bit. Yeah. There we go. Bill's new car loan statement said he would pay $4,866.25 in interest from a simple interest rate of 8.5% over 5 years. How much did he borrow to buy his new car? So again, we're putting the unknown over on the right-hand side of the equation this time, where it was on the left-hand side yesterday. And I'll tell you what, while you guys work on that, I'll be right back. I'm going to get some water. Sometimes, fellas, when we do a problem that involves percent or interest or whatever, it's helpful to have a calculator at your disposal. I don't know if you guys carry a little 4-function calculator around with you. Your smartphone has a calculator on it too that can do computations. So when you're multiplying or dividing decimals, don't be ashamed to whip out the old calculator and go to town on it. Okay, just a word to the wise. Alex, you carry a calculator? You carry one of these? Get it out. Use your calculator app. Y'all don't sit there, fellas. Figure it out. I'm going to do it on my end. 866.25 divided by equals it. Divided by 0.08 equals that. Ooh, I got an answer. Who else has an answer? Mossy, you got an answer yet? Oh, you're doing, whoa, I see. Doing some long multiplication with those decimals. All right, so what was our formula again, Quentin? Can you remind us of it? You don't have it written down? I circled it in red a moment ago. Here it is. I equals what? PRT. Write that down, brother. I equals PRT. So interest, the amount of interest in a simple interest scenario equals the principal investment times the interest rate times the duration, right? And Lewis, remind us about that interest rate. What does it need to be in terms of?
What do you mean? Like
it was given to us. It was given to us as a percentage, and we said that whenever we're doing calculations with percentages, what must we do first?
Make it a decimal.
We must convert it into a decimal. Tiago, do that for me, please, sir.
0.085.
Beautiful. All right. What is the duration, Luke? 5 years. All right. And they told us that the amount of interest was 4866.25, which means that the principal investment, in other words, how much he had to borrow initially. That's what's weird about this one, right? That's what's different. Is it used on the first one we were given the principal rate and time, and we just had to multiply all three of them to get the interest. Here they give us the amount of interest. They say to borrow this car, you're going to have to pay 4866.25. So when we do this, we divide both sides by whatever 5 times 0.085 is. 0.085 times 5, divide, and we get 11. What do we get? Somebody got that number? My phone just fell asleep. What do you got? Call it out. 11,435. Plus 11,450. And that's how much money it would cost principal wise. So this is a good life lesson, right? This will be the sticker price of the car. Okay, so you're walking around the car lot. Bill is walking around the car lot, and he sees this vehicle, and it's got this sticker on it, and he thinks erroneously, yes, if I have $11,450, I can afford this vehicle, which is totally not the case, right? Because he's going to have to pay $11,450 plus $4,866.25 in taxes or interest or whatever it is. Interest, excuse me. So, when you guys are doing you're shopping around looking for things, always remember, you got to pay tax, you got to pay interest if you're borrowing money, that type of thing. Ideally, we don't borrow money, we pay for everything up front. That's a good habit to get into, just personal opinion there. Do you guys know what the sales tax rate is in Tennessee? 0.9. I think it's 9.25. It might have been raised since last I looked. But yeah, you would calculate it just like I think maybe Tiago did for us, where we put it as a decimal, right? So you can do even now, like my mountain bike team. My kids are buying they got a deal where we got 40% off Camelback hydration packs, right, for the team. So they're going online and they're looking at little hydration packs or whatever, so they can ride their bike and drink their water and be happy and all that good stuff. And so like if they look at a hydration pack online and it says that's $45, then they need to remember to compute not just the $45, but to also budget for tax and shipping and things like that. So be a savvy consumer, and also remember your formula, right, Quentin? Attaboy. Okay. Any questions on that last example? All right, we're going to move on to something new, which I probably should have done this already. Hold on, let's see here. I'm going to make a new copy of this, so it'll be blank for you guys. Copy and paste. This morning on the radio, I love calling into the radio, by the way. Does anybody else do that? You guys ever call in on the radio? Mossy's like, no, we do not call into the radio, Coach Morgan, because we're not weird like you. Well, anyway, I'm sitting in line at the Chick-fil-A, and Ron and Karen on 104.5 The River are talking about cheeseburgers. And they're like, hey, what's the best cheeseburger place in Memphis? Where's the best cheeseburger you've ever had? And so I thought, I've had a great cheeseburger. I was talking about it on Wednesday to my buddy Philip. By the way, here's your warm-up question while I'm meandering around conversationally about cheeseburgers. Y'all can work on this. And so I called in, and Ron was like, hey, what's your favorite cheeseburger? And I said, man, the best burger I've had ever was at Spring Creek Ranch, this golf course, fancy private golf course. I had a buddy that invited me to play out there, and afterwards we ate the most delicious cheeseburgers. I mean, they were on like this sweet brioche bun, and they had like lettuce and tomato and onion, and I think they even put a piece of avocado on there, getting fancy, okay, Mossy. And then, of course, it was the burger patty was like this thick, and it had cheese all over it. Am I making y'all hungry, Ben? Yeah, you guys fans of the burgers? Anywho, so I told Ron all that, and then so they had a little segment about the cheeseburgers, and they listened to people like me call in and give the best burger place. And then afterwards, they played Jimmy Buffett's Cheeseburger in Paradise. And so it's been stuck in my head for the last, 45 minutes or so, which is why when you guys were checking in here in the courtyard, I was singing that Cheeseburger in Paradise song. Good stuff. Uh-oh, somebody's left a meeting chat note. Who is this? Jack McBee said his internet is acting up. Alex Wynn, I'm thoroughly disappointed, son. I thought you were going to take the initiative and chat me your favorite burger joint in Memphis. So, it's quite a letdown. Your business as usual, Mr. Wynn. That's okay. I forgive you. But I tell you what, if you guys are at home and you do have a fancy burger place that you like to go to, why don't you leave me a recommendation in the chat, and then I'll have a new place to go. Maybe we'll see. And don't say Huey's. Everybody always goes to Huey's. I love Huey's. That's great, but I want something new and fancy that I have not tried before. We'll see. All right. As you guys are kind of looking at these 3 warm-up questions, I'm going to go ahead and mention that our lesson today, the main gist of it, is all about using inverse operations, not just with numbers, but with letters as well. I'm going to give you some formulas, and we're going to play around with those formulas because it might be helpful to look at. Like, for example, distance equals rate times time. Okay, distance is already solved for, but maybe I want to get rate by itself. And so we're going to talk about how you can achieve that type of thing. And some of the skills that we use today are going to involve these 3 warm-ups. When I say, Alex, when I say evaluate, what's another way of saying that? Or what are we asked to do here on number 1? What does evaluate mean? Did I dadgum ask Paul or did I ask Alex? What do you think, Alex? And by BT dubs, Paul, we're not solving anything because there's no equal sign there. Although I know you see an equal sign right here, but I'm talking about over here. Like, how would I work number 1? What would you suggest I do? 5 plus 3 instead of x plus 3. So in other words, we plugged in, or we substituted x equals 5. Good. So 2 times the quantity of 5 plus 3. And then, Paul, which one of those do I need to do first? Yeah, we're going to follow our order of operations. Guys, to evaluate means to figure out what number that equals. That's putting it in layman's terms, right? To figure out what number it equals. So we got 5 plus 3 is 8 times 2 is 16. Easy peasy lemon squeezy, okay? The length of a rectangle is 3 less than twice the width, W. Now, guess what I'm going to do for this one? Whoops. I'm going to draw a picture, okay? Anytime you guys have a word problem where there is like a geometric figure, draw a daggum picture out, okay? No joke. It could be the easiest problem in the whole wide world, but I still want you to get in the habit of drawing a picture. Okay, so there's a rectangle. Boom. And it says the length is 3 less than the width, twice the width. So if the width is W, okay, Joe, what expression can I use for the length? Beautiful, son. Beautiful. 2W minus 3. Couldn't have said it better myself. Reason being is that it says 3 less than, and that's that inverted sentence structure, isn't it? We talked about that earlier in the week. If I say my height, 3 less than my height, 3 less than my height would be my height minus 3. So 3 less than twice the width will be twice the width, minus 3 twice the width, obviously, is 2 times the width, okay? So there's my picture, and it says write an expression for the perimeter. I wonder if Mr. Jake Oxley knows what perimeter means. All right, so going around all 4 sides in this case. There used to be a game, I hate to admit it, but I played it every once in a while, called Rainbow Six. And it was like one of those first-person shooter, kind of go on a mission and kill a bunch of bad guys kind of game. You guys familiar with that? Yes. I think they've got iterations of that game that have come out since then. But this was back in like early 2000s, like 2000, 2001. And so Rainbow Six, Tom Clancy, I think is the writer of those books. Anyway, you would one mission, they had a compound where like the bad guy was hiding out in the compound, like Osama bin Laden or something. And you had to go do a perimeter sweep before your SEAL team or your whatever, your Rainbow Six guys could bust up in there and get the bad guy. And a perimeter sweep was what? We went around the outside of the compound, clearing it of hazards and bad guys. Okay, so when you think of the word perimeter, that's exactly what you're doing. Like Jake said, you're going around the outside and you're tallying everything up. Okay, so that just means that we want to combine like terms from our 2 lengths and our 2 widths. Okay, if you want to be fancy, you can consider perimeter to be equal to 2 quantity L plus W, or you could just say 2L plus, my elbow was hitting the keyboard, 2L plus 2W, or if you want to be kind of a slow play it, you could say L plus W plus L plus W. Okay, that's kind of the formula working in the background here. We don't need the formula because we've already got our picture drawn out. So what does it wind up being? We've got 2W minus 3. We got 2W minus 3. So that looks like 4W minus 6. And then add on a couple more W's. So that's 6W minus 6. And that would be our expression for the perimeter in terms of W. Okay, Charlie, what would my area be? Yeah, very good. So if perimeter equals where we add all of the sides up, area of a rectangle is where we do length times width. Isn't that right? So we would say area equals W times the quantity 2W minus 3. And if we wanted to use distributive property, it'd be 2W squared minus 3W. Okay? So again, getting you guys used to notions of about formulas. Okay? Now, this last one, number 3, let me call on somebody at home. Let's see here. Grove? Can you hear me, Grove? Thompson, can you hear me? Earth Thompson, unmute your mic, bro. All right, we're gonna pitch it over to Nate Dogg. Nate Brownlee, what's this the formula of? Nate, you seen this formula before? Okay, Nate's not answering. How about Reed Johnston? Getting a little grouchy. Lewis, can you hear me? Lewis, you are my saving grace, son. I'm trying to call on somebody that's at home today. Ain't none of these jokers answering. What do you think, Lewis?
I actually don't know.
That's all right. That's all right. Let's see here. We'll go with Ben Rouse. Formula for the what of a triangle? The area of a triangle. Good. Hey, and there's a few fellas. This is the area of a triangle equals 1/2. What do y'all think that B stands for? Base. I'm all about that base. And then the H stands for height. Okay, I realize that was weird what I just said. Sorry. It's okay. Just trying to be a little goofy today for you guys. Evaluate just means plug and chug. So what's 1/2 times 14? That's 7. 7 times 9 is 63. So we got a nice area of 63 for number 3. I'm ready to get into this. How about you guys? Y'all ready to roll? All right, so like I said, what we're going to do is we're going to practice manipulating some formulas today. And I got a couple of, we won't say well-known, but a couple of formulas that maybe you've encountered before on the screen here. Let's write both of those down. We're first of all, on number 1, we're going to get H by itself. We're going to solve for H. Okay. Now, this is a volume formula. This is the volume of a cone. All right, volume of a cone. You guys know what a cone is? All right, like ice cream cone. A mathematical cone. Looks just like that. There's your R. That stands for what? Radius. And then there's your H. And that stands for height. Okay. Anyway, just sprinkling in some little extra tidbits of knowledge for you guys today. This is the volume formula for a cone. We won't get H by itself. So on this one, what we're going to do is I'm going to help you peel back the layers one at a time. Okay. We're going to peel back the layers one at a time. And we're going to start with that 1/3. Okay. So James, what do I do to both sides to get that 1/3 over? All right, it's being multiplied. What undoes multiplication? Division. So we could divide both sides by 1/3. Now, dividing Mr. Benton by a fraction is the same thing as multiplying by the louder reciprocal. Good. And to kick it back to James now, James, what's the reciprocal of 1/3? Three over 1. Very good. So in other words, if I've got 1/3 as a coefficient, technically what we're doing is dividing both sides by 1/3. Another way of looking at that is to say, oh, well, hey, just multiply both sides by 3, right? Because what's 3 times 1/3? 1, and we are fine with having a coefficient of 1. All right, so this one winds up being 3v equals pi r squared h. All right, so we're peeling back the layers. We just took care of that first coefficient. Now we want to take care of the next coefficient, which is pi. Pi is approximately what? 3.14, good. Do I want to divide both sides by 3.14? Why or why not? I love a good awkward silence. That's how a lot of my first dates went. Just kidding. Tiago. No. Correct. Why would we not want to just divide by 3.14? Yeah, pi is not deadgum 3.14. Pi is pi. Okay. So if we want to divide both sides by something, let's divide both sides by by pi instead of 3.14. Okay. So we're going to divide both sides by pi. Okay. Now I'm on the right hand side. I've got r squared times h, and over here I just got 3v over pi. Nothing simplifies out over there on the left side, and that's okay. I'll just leave it as 3v over pi. All right, Monty, what's my last step to get h by itself? I got to divide one more thing. Divide both sides by r squared. All right, so divide both sides by r squared. I'm kind of out of room, so let me get myself some more space. Hold on. There we go. Now we got plenty of space. All right, so that right-hand side now is h. Woohoo! And then the left-hand side, we've got a fraction on top of r squared. And I don't know about you guys, but in my parents' house at home, there is what's called a trash compactor. Anybody got a trash compactor at maybe their grandparents' house or something like that, or at your house, right? The gist of how a trash compactor works, fellas, is like here's a countertop, right? And in my mom and dad's house, you know, here's the sink. They got a couple sinks. There we go. We got water, and then you know, like here's some cabinets and whatnot. But this is the trash compactor right here. It's got a little handle, and you slide it out, okay? And so when you slide it out, what happens is this garbage receptacle, okay, that you would, you know, dump trash into, and then you would slide it back in there, and you push a button, and it goes, and it's got like this, you know, this hydraulic or this screw press that it smooshes all your garbage down for you. Okay, it's called a trash compactor. And I guess they're kind of old school, maybe technology from the 80s or 90s or whatever, but my parents use it, and it's pretty handy dandy. And I like to use it when we're doing a problem like this. We're going to use what's called the compactor method, okay? This is a Coach Morgan colloquialism here, where if you go to your school and you say, yes, we use the compactor method, Miss Bledsoe, she's going to be like, what are you talking about? So if you have a fraction on top of a non-fraction, right, and you want to simplify things, dividing is the same thing as multiplying by the reciprocal, right? So like doing over here is we say 3v over pi divided by r squared is the same thing as times 1 over r squared. That's timesing by the reciprocal. And then you would just do top with top, bottom with bottom, and you'd get 3v on top, and you'd get pi r squared on the bottom. But for me, I like to consider it the compactor method. We just, let's squish that pi down there with the r squared. Let's push him down there with his buddy, and what we wind up with is 3v on top, and then pi r squared on the bottom. Okay, so when you got a fraction on top of a non-fraction, just compactor method. And we got h by itself. Now, we could have done this a lot quicker. I know that. But what I wanted to show you guys is we could go one step at a time. We could take out, what did we take out first? We took out the 1/3, and then we took out the pi, and then we took out the r cubed. We peeled back the layers one at a time. Okay? We could have gotten rid of all of them all at once, but for illustrative purposes, we took it nice and slow on this first one. Okay, questions on this one? How we got h by itself? You know, feel pretty comfy? Let's look at the next one. Okay, let's see here. Luke, you strike me as being a science-minded guy. This is a formula from science class. What is this formula? Oh man, pish posh. Ooh, it's Luke. It's getting kind of hot in here. Let me go ahead and turn this thermostat down. Let's see here. Hold on. I need to change the temperature in here. Okay, Luke. What did you have like a fault in the last minute? What?
Yes, I think it might be Celsius and Fahrenheit.
That boy. I knew you were science minded. That a kid. Yeah, it's a conversion from Fahrenheit to Celsius. Okay, and it's pretty common fare for 8th grade. Like, what do y'all take? Like natural science or earth science or something? Physical science? Just science. Just good old science. My 8th grade science teacher, I loved her to death, man. Her name was Mrs. Eubanks. And Mrs. Eubanks was a sweet lady. I don't know if her husband had died or not. I think she lived by herself with her dog Muffin. And her dog Muffin was like this little bitty, kind of yippy, like little baby-sized dog. And Muffin would go everywhere with her. She'd take Muffin to the movie theater. Muffin would sit in her purse in the movie theater, okay? And our 8th grade year, poor Mrs. Eubanks, Muffin died. And I thought that lady was not going to make it. I mean, it was like the loss of a child. It was so tough. But anyway, that's what I remember about 8th grade sciences. Muffin and temperature conversions, okay? So in this case, what we want to do is we want to get F by itself. We need to peel back those layers, okay? We need to peel back the layers. What's the outermost layer that's being done to F? What do you think, Oxley? 5/9. How do I go about getting rid of a fractional coefficient? Well, we multiply by the reciprocal. Okay, and Alex, what's the reciprocal of 5/9? 9/5. So we're going to multiply both sides by 9/5. Okay, so 9/5 C equals F minus 32. And then the last step, okay, the last step would be to add 32 to both sides. All right, so we got F equals 9/5 C plus 32. Okay. And that's how you would change from having C solved for to having F solved for. And that makes pretty good sense because, like, let's say I memorize C equals 5/9 times quantity F minus 32. Let's just say I have that memorized. Okay. Well, that's fine if I am needing to convert something into Celsius. But let's say I'm traveling overseas, or let's say I'm up in Canada and I need to know there, and they're like, oh yeah, it's 40 degrees, yo. And I'm like, okay, I don't know what 40 degrees means, but it ain't that cold outside, okay? And I need to do a quick conversion, right? Then all I have to do is, plug in 40 degrees into this blue equation down here at the bottom. 40 times 9/5. I'm kind of curious what 40 degrees is. Can you guys do that for me? What? Well, let's take and figure that out. Let's call Quentin's bluff. He says it's very hot. Let's see if it's very hot. Plug in 40 for C, and you guys see if you can evaluate, like your warm-up question, right? Evaluate what you should get in terms of F. All right, let's do this. 9/5, 40. 40 over 5 is 8. 8 times 9 is 72 plus 32. Ooh, doggy, you're right. Did you guys get 104?
Yeah, because 0 degrees Celsius is 32.
And 100 degrees Celsius is?
Very hot.
Does anybody know what the boiling point is of water in Fahrenheit? Do what? I think it's 212. Let's see if the old Google machine can help me here. I bet Siri would have been faster, but oh well. What is the boiling point of water? 212. Bingo. So anyway, Celsius, there you go. Celsius is based on, by the way, freezing point, as Clinton mentioned, and boiling point of water. But I'm sure you guys knew that. 0 degrees freezing, 100 degrees boiling. Awesome sauce. All right, last one, I think. We got time for it. Yeah, we do. Does anybody know what this area formula is for? What shape? A trapezoid. That a boy. Drew Benton, the geometry scholar. All right, so we got A equals 1/2 H quantity B1 plus B2. What do y'all think B1 and B2 stand for? The bases. The two bases. Base on the bottom, base on the top. And of course, H is the height. So I don't care about A. I want to know what B1 is. Y'all get B1 by itself, and then the lesson will be yours. Heinz 57 and French fried potatoes. It's a classic, Joe. It's a classic. Again, let me challenge you guys, get rid of that outer layer first. Think, what should I do to get rid of my outer layer? What's being done on the outside? And then tackle the inside. I need to check our chat log, see if anybody's giving me some good burger recommendations. Nope. Let's see here. John's Week says Freddy's. That a boy, John. Farm Burger at Crosstown Concourse. Okay. Hop Dotties. Or what the dump is Hop Dotties?
It's over near White Station.
Hop Dotties? I ain't never heard of that place. That sounds cool. Lewis Thomas, I'm gonna give you a thumbs up. Alex Wentz says Cookout. Come on, Alex. You can do better than pick up Cookout. I'm gonna give Zweig a thumbs up. Freddy's has good little ice cream also. My kids like their dirt and worms.
We had Freddy's last night, and then I had to take some Tom's.
Oh no. What'd you get from Freddy's? Just a regular old.
Got their chicken sandwich and fries.
I don't know if I've ever had their chicken sandwich. Do you normally like it?
I've only gotten it twice, but it's like I don't
Gotcha. They give you a lot of fries. They give you a lot of fries. All right, let's wrap things up here. Ben, what do I do first? And dividing by 1/2 is the same thing as multiplying by? Good, let's multiply both sides by 2. So I got 2a equals h, b1 plus b2. All right, and then my next step, Paul, would be, no, dadgummit, we want to get b1 by itself. Move what? Move the h over. We're going to divide both sides by h. So I got 2a over h equals b1 plus b2. Now, some of you guys, some of you cool cats out there might have thought it would have been a good idea to distribute the h. And that would be making more matters more complicated for you, okay? Last but not least, we're going to subtract b2 from both sides, and I'm way out of time. We're sitting here chit-chatting about burgers, and time has slipped away. So y'all pack up and skedaddle on out of here. We got b1 is the same thing as 2a over h minus b2. Very good, very good. I hope you guys have a fantastic weekend. Enjoy the weather, get outside and enjoy nature. Go for a walk with your mom or your dad, and I'll see you guys on Monday. Live Jesus in our hearts. All right, thank you so much. Sorry I held you a little bit later. Wendy's?
Yes.
I'm familiar with the Wendy's.
Yeah, Wendy's. There's a new place. Well, it's not new, but it's been like
Are you saying Wendy's like,
Wendy's.
spell it?
Wimpy.
Wimpy's.
Yes.
Oh, that's a throwback to old Pop